September 15th, 2025. 28 near-Earth objects detected in a single week. The statistical probability of this happening naturally, less than 1 in 1,500. But what's keeping planetary defense experts awake isn't just the numbers, it's the precision, the timing, the way these objects seem to arrive in perfect sequence, almost as if synchronized. Most years, astronomers detect maybe 8 objects passing closer than the Moon in an entire month. September 2025 delivered that number every 2 days, compressing decades of statistics into a single week. Coincidence? Or something far more deliberate? The numbers don't lie. ESA's NEO Coordination Center had cataloged 38,307 asteroids by May 2025. Detection rates were climbing, roughly 8 new objects every day. But September's spike represented a 350% increase over baseline expectations, a statistical outlier so extreme, some called it a cosmic lottery ticket. Dr. Marco Micheli from ESA admitted, "In 20 years of tracking near-Earth objects, we've never seen clustering like this. This wasn't random noise. This was order emerging from chaos." But here's what makes this unprecedented. The clustering pattern followed gravitational mechanics too perfectly. Objects arriving from different regions of space, yet converging on Earth's neighborhood with mathematical precision that defies random distribution models. The Minor Planet Center's public logs show no comparable event since digital tracking began. Even during known asteroid family breakups, objects scatter across years, not days. The striking cases. 2025. EFA 22 tells the most chilling story. A 290-meter asteroid, the size of the Chrysler Building, passed Earth on September 18th at 842,060 kilometers. To visualize, traveling at 38,600 kilometers per hour, it could cross the United States in 8 minutes. Even stranger, FA-22's orbital period is 1.86 years, meaning it's been visiting the inner solar system regularly, perhaps for centuries. Always predictable, always on time. Then came 2025 RJ-2, smaller, 40 to 80 meters across, but far more unsettling. It wasn't detected until 5 days before it skimmed by at just 301,306 kilometers. That's closer than the Moon. Think about it. An object capable of leveling a city, spotted less than a week before arrival. That's not planetary defense. That's planetary roulette. The International Asteroid Warning Network scrambled. Pan-STARRS in Hawaii, Atlas in Chile, Catalina in Arizona, and ESA's brand new flyby telescope all pointed skyward. This wasn't science. This was crisis response. But the most disturbing detail? Both objects exhibited identical approach vectors, threading through space along nearly parallel trajectories, as if following predetermined flight paths. The conventional explanations. Scientists offered 2 explanations. Fragmentation hypothesis. A larger asteroid broke apart. Dr. Detlef Kushny from ESA wrote internally, "The orbital resonances suggest a common origin. This may be a debris field from a breakup 6 months to 2 years ago." Detection bias, NASA's favored explanation. Our telescopes just got better, revealing swarms that were always there, like swapping binoculars for Hubble and suddenly discovering more stars. Both sound reasonable. Both fall apart under scrutiny. Spectroscopic analysis showed FA-22 and RJ-2 shared near-identical mineral fingerprints, olivine and pyroxene, like fragments of a shattered planet. but their thermal signatures didn't match any known asteroid classification. Dr. Amy Mainzer from NASA's JPL confessed privately, "Some near-Earth objects exhibit unexpected thermal properties that challenge our classification models, puzzling us with anomalous infrared readings. Even stranger, FA-22 spins with the precision of a Swiss watch, 4.2 hours exactly. Natural asteroids tumble chaotically. This one doesn't. The thermal anomaly extends beyond surface composition. Both objects maintained consistent infrared signatures throughout their approach, showing none of the expected temperature variations as they moved through different solar radiation zones, patterns that shouldn't exist. Both FA-22 and RJ-2 have orbits under 2 years, meaning they passed through Earth's neighborhood before. FA-22 in early 2024, RJ-2 in mid-2024. So why weren't they seen then? Were they deliberately avoiding detection? Until now. Dr. Richard Binzel from MIT offered the unsettling answer. We may be systematically missing entire populations of near-Earth asteroids, hidden by orbital configurations, or camouflaged by observational bias. Remember that precision we talked about? That timing? It wasn't cosmic luck. It was coordination. The Moon itself offers supporting evidence. Studies of impact craters show clusters of strikes separated by short geological intervals. The Apollo samples contain shocked minerals from multiple impacts that happened close together in time. Dr. William Botke put it bluntly, impacts may come in waves, not random strikes. But here's where conventional explanations break down. Computer models of asteroid family dispersal show that even catastrophic breakups spread debris across orbital periods spanning decades, not days. For 28 objects to converge simultaneously requires either unprecedented gravitational focusing or external coordination. Imagine a convoy of trucks barreling down a highway. 1 or 2 you might expect, but 28 in formation, all taking the same exit at once, that doesn't happen by accident. The dark possibility. If impacts cluster naturally, our defense models are wrong. We're not spinning a roulette wheel of random strikes. We're standing in the path of cosmic shotguns where multiple shells arrive together. But what if it's not natural at all? Consider this. An advanced reconnaissance effort could deploy survey probes disguised as asteroids, objects with orbits timed to slip into view only when detection tech reaches a certain threshold. The September 2025 swarm may not have been an accident. It may have been a test to see how we'd react, to see if we were watching. The timing supports this theory. Our detection capabilities reached unprecedented sensitivity in 2024 to 2025, with the Rubin Observatory achieving first light and multiple sky surveys operating simultaneously. If something wanted to test our monitoring systems, September 2025 would have been the perfect window. The object's behavior patterns suggest systematic observation rather than random encounters. Their synchronized arrival, anomalous thermal signatures, and precise orbital mechanics point to coordination rather than chance. Most troubling, the way they remained invisible during previous passes suggests sophisticated timing algorithms, appearing exactly when our technology reached the threshold to detect them, but not before. The next chapter. NASA's upcoming NEO Surveyor mission will launch in 2027, positioned at Earth's L1 point to see what's hidden in the sun's glare. If September 2025 was natural, we'll see more swarms. If it wasn't, the silence may speak volumes, because the September swarm wasn't random. It wasn't natural. It was an announcement. And now that we've proven we can see them, what comes next? Just weeks later, another visitor appeared, 3I/ATLAS, moving at 200,000 kilometers per hour, glowing from the front, defying physics in ways that make the September swarm look conventional. The September swarm was the opening act. The real story was still to come. Because if September 2025 was a test, did we pass? Or did we just reveal exactly how defenseless we really are? The universe just reminded us that we may not be the only ones watching. And now that we've seen the pattern, we can never unsee it. In Cosmos, we trust.